Hi, it's time for another math easy solution. To discuss further into the polar coordinates example 9 video series, which looked at the cardioid or heart-shaped polar curve. And now go over part 4 of it. In my earlier videos, I went over parts A and B, as well as in part 1, I just went and solved the slope of the tangent line formula for the cardioid polar curve r equals 1 plus sine theta. And in this video, part 4, I'm just gonna go over that same slope formula, but in a calculated in a different way, and basically recall from part 1. So make sure to watch that. I showed that you can write the polar coordinates equation, or basically use the parameter theta as a parameter in a parametric set of equations y and x, and then use the derivative formula for parametric curves. So y equals r sine theta, x equals r cosine theta, and I went over in part 1 and I solved the derivative dy over dx, or the slope of the tangent line, equals to dy over d theta divided by dx over d theta, or the derivative of y in terms of the parameter theta, and then this is derivative of x in terms of theta, the parameter. And then I show that it equals to cosine theta 1 plus 2 sine theta divided by 1 plus sine theta 1 times minus times by 1 minus 2 sine theta. But there's also another way to solve this. If you saw my part 1 video, it was pretty extensive trying to solve for that, but we could have done something else. So note, we could have also done, so another way we could have done was first take note that, well, y equals to r sine theta, for example. This just equals to, well, if we just plug in the formula for r is 1 plus sine theta, so we could have just skipped to do it like this, 1 plus sine theta. Again, it's just different ways of solving it. I like this way better than the one I did in part 1. So r is 1 plus sine theta times it by sine theta, and then this top part's going to be equal to, multiply that out, sine theta plus sine squared theta. And then for the x coordinate, or the x equation, x equals to r cosine theta. This equals to, just plug in r, 1 plus sine theta times it by cosine theta. Now multiply this out. This is going to equal to cosine theta plus sine cosine theta, like that. Now for this one, we know the trig identity. Basically recall the trig identity. Sine 2 theta equals to 2 sine theta cosine theta. But now what we could do is basically just remove this 2, just divide the 2 out. Let's put it over here like that. So then this equals to 1 over 2 sine 2 theta. So put this over here. This equals to cosine theta, write a better cosine theta plus 1 over 2 sine 2 theta. Yeah, so what we have now is, well, if we take the derivative, and now we have x and y in a simpler way like that. So dy over dx, again, this equals to dy over d theta over dx over d theta. So the derivative of y in terms of theta, that's going to be sine theta, as the derivative is cosine theta, and then the derivative of sine squared theta, that we could put the 2 down, and then it'd be 2 sine theta, and then times it by the derivative inside of sine theta. That's going to be cosine theta, just using product rule. And then where this 2 sine theta, cosine theta, that just equals to, well, this sine 2 theta. And then divided by, take the derivative of the cosine. Cosine's over there, so derivative of cosine is negative sine theta, and then derivative of sine 2 theta, the 2 goes down, and then we have derivative of sine 2 theta, which is going to be cosine, this is just cosine 2 theta. Yeah, so it's cosine 2 theta, then the derivative inside 2, so the 2's cancel, 2 over 2 just cancels. It's again used product rule because the function inside is 2 theta. So that's what we have now. And basically we could have just stuck with this one over here. Or actually just write it down and simplified this one here, so we get dy over dx equals to cosine theta plus, now this one that's just sine 2 theta over minus sine theta plus cosine 2 theta, and see a pattern as cos. Now you have this one cos 2 theta, sine 2 theta, this is just sine theta. So yeah, this is actually the same as above. Yeah, so this formula is, I'll just write same as above. And so same formula as this one over here, and I'll prove that actually. So this one here, it's actually the exact same thing, and I'll show you that right here. We're just going to work backwards now to show you. And basically, if you saw my part 1, it was much more complicated in trying to solve for the derivative as opposed to this one. It looks different, but they're actually the same, and this one I like this method much better. So now just to show you what we can do is basically try to match the numerator with this numerator, and then the denominator with the other one over here. So what we could do is, well, notice this top one, all we do is take the cosine, if you multiply that out, that's actually the exact same thing here. So yeah, so I'll just go over from here and write it out as the above formula. So cosine 2 theta equals 2, expand this one, cosine theta plus 2 sine theta cosine theta, then just factor out the cosine theta like that. Then we have a 1 plus 2 sine theta, which is the exact same as the numerator above here. So we got that part correct. Now we just need to do is find this those two factors at the bottom, 1 plus sine theta and 1 minus 2 sine theta. So if we look at this numerator, the denominator there, we have this negative sine theta cosine 2 theta. But first what I'm going to do is recall the trig identity. In my earlier video, I put a link in the description below for cosine 2 theta. So cosine 2 theta equals to 1 minus sine, actually this is a 2, 1 minus 2 sine squared theta. Yeah, so if we just recall that trig identity, now we could plug that inside there. So what we have is negative sine theta plus cosine 2 theta equals to negative sine theta, and then we plug this one inside here, or this inside there. So we have now plus 1 minus sine squared theta, like that. And in fact, now we could just rearrange this, put that in front. This equals to negative, I forgot the 2 there, so negative 2 sine squared theta minus sine, put that in this order, and then plus 1 over there, and we could factor out the negative 2 like that. So we have a sine squared theta like that. Negative 1 divided by negative 2 is just, well, plus 1 over 2, and then 1 divided by negative 2, that's just negative 1 over 2. This is going to be sine first. Then we factor out 1 from there. Negative 2 from 1. 1 divided by negative 2 is just negative 1 over 2, like that. And now if you saw my earlier video in part 1, we already covered this exact one right here. So from part 1, well, and you could also just factor by guessing. Yeah, let's put this from over here. So from part 1, we already covered this exact one, but you could also factor by guessing. So make sure to watch my part 1 video to see how I get from here in more detail. So negative 2, now we could just factor this out by guessing. So sine theta, so we need a number, the two numbers that multiply by each other that add up to 1/2. But then multiplied to negative 1 over 2, and that's actually 1 right here, and sine theta minus 1 over 2. So 1 minus 1 over 2 is over here, 1/2, but then 1 times negative 1 over 2 is this one here. So that's from part 1. You could also factor by guessing. So make sure to watch that one and see it in more detail. Now we can just multiply this negative 2 inside. To make it simpler, we'll multiply it inside over there. So we get and I'll rearrange this so it looks like the above formula. So this is going to be 1 plus sine theta. So rearrange it like that. Let's write this neater. 1 plus sine theta. And now we multiply this inside. Negative 2 times 1 divided by 2. Well, that's going to be positive, and the 2's cancel. So we have 1. I'm going to move that in front. And then minus 2 sine theta. Like that. And this is, in fact, the denominator. So that's 1 plus sine theta, 1 minus 2 sine theta. Like that. So that's the exact denominator. Yeah, so thus we can just combine these all together. Thus the derivative dy over dx is equal to, well, in both ways you could write it as cosine theta plus, this was sine 2 theta, the one I just solved above, and then negative sine theta plus, this was cosine 2 theta. And this also equals to exactly as above formula, or from part 1, which is cosine theta 1 plus 2 sine theta divided by, and let's see if I remember, yeah, that one's over there actually. So 1 plus sine theta 1 minus 2 sine theta, like that. Let's write this neater. Yeah, and there is what we have, like that. And yeah, so you can write them in both ways. They're the exact same. I like this one better than the part 1 way I solved it. This one's easier and quicker, and actually looks nicer too. It just involves these 2 thetas, like that. And cosine 2 theta, sine 2 theta. Anyways, that's all for today. If you learned from this, yeah, this is the last part, and I believe last part. I might do part 5 if I find something else. But anyways, thanks for watching, and like always, you can download these exact notes in the link below, as well as I'll be posting these notes in article format in steemit.com, so check it out and follow me at MES. Anyways, thanks for watching, and stay tuned for another Math Easy solution.